Here we have a SAT math question. Okay, let's go to the information. Y equals to 2x square negative 18x negative 40. Y equals to 2x negative c. In the given system of equations, c is a constant. The graphs of the equation intersect at only one point a comma b in the xy plane. What is the value of a? Okay, here we have a quadratic function and linear function. So for a quadratic function, we'll be getting a graph parabola, or for linear function, we'll be getting a line. Okay, the parabola and line intersect exactly at one point. So the point of intersection is given, that is a comma b. At the point of intersection, they are asked us to find the value of a, so which is the x coordinate at the point of intersection. Okay, so for that we have to solve the given system of equations. To solve the given system of equations, I just write y equals to y. So for this y, I am taking the stuff from the first function, first equation. So that is 2x square and negative 18x negative 40. And for the y on the right side, I'm getting the stuff from the second equation. So that is 2x negative c. Okay, now actually it's a quadratic equation. So to get the quadratic equation standard form, we have to write everything on the left side and the right side must be 0, so that we can solve the quadratic equation. Okay, so to make the right side 0, I subtract 2x from both sides and I add c to both sides. Let me do it. Okay, when I do so, this positive 2x, negative 2x will cancel. The same thing over here. I'm getting 2x square negative 20x negative 40 positive c, or it can also be written as positive c negative 40 equals to 0. Okay, now I got the quadratic equation. So if I solve a quadratic equation, usually when we solve a quadratic equation, I will be getting two values for x. But in some quadratic equation, we'll be getting only one value. So that is, we'll get two values, but both the values will be same. But here, according to the information, the graphs of these two equations intersect at only one point. So even if I solve this quadratic equation, I'll be getting only one value for x. That is, I'll be getting two values for x, and both the values will be equal. But if I want to solve this quadratic equation, I must be knowing the value of this unknown constant c. So how do I have to find the value of this unknown constant c? So since the question says the two graphs intersect at only one point, even when I solve this quadratic equation, as I said already, we have only one solution. So let's consider a quadratic equation standard form ax square positive bx positive c equals to 0. If this quadratic equation, we have to find the value for the discriminant b square negative 4ac. If the value of this discriminant b square into 4ac is greater than 0, then we have two real solutions. In case if the b square into 4ac equals to 0, then we'll have only one real solution. And if the value of this b square negative 4ac is less than 0, then no real solution. Okay, since we have only one point of intersection for the two graphs, so this quadratic equation must have only one solution. So if I find the value of this discriminant b square into 4ac for this quadratic equation, it must be equal to 0, so that we'll have only one real solution. Okay, now our aim is to find the value of the discriminant b square negative 4ac in our quadratic equation. For that, we have to compare the quadratic equation over here with ax square positive bx positive c equals to 0. So when I do such comparison, I am getting a equals to 2, which is the coefficient of x square, and b is equal to the coefficient of x, that is negative 20, and c is a constant term. In this case, c equals to c negative 40. Okay, now let me find, if I find the value of the discriminant b square negative 4ac, so for this one, it has to be equal to 0. But because this quadratic equation will have only one real solution, because there is only one point of intersection. Okay, now let me find the value of the discriminant. Let me equate the value of the discriminant b square negative 4ac to 0. So now we can plug in the values for b, a, and c. The value of b is negative 20. Then I'm getting negative 20 the whole square. Negative 4 times the value of a is 2. The value of c is c negative 40 equals to 0. Okay, so if I evaluate negative 20 the whole square, it is just 400. Negative 4 times 2 is 8 times c negative 40 equals to 0. So 400, when I distribute this negative 8 to c, it will become negative 8c. So negative times 8 will become positive. 8 times 40 is 320 equals to 0. Okay, now, so when I combine this 320 and 400, I'm getting 720. Negative 8c equals to 0. Now I subtract 720 from both sides. When I do so, this positive 720, negative 720 will cancel out. Negative 8c equal to negative 720. Let's divide both sides by negative 8. So negative 8 will cancel, negative will cancel, 8 goes into 8 one time, so 8 goes into 72 9 times, and we have 1 0 here. So then I'm getting c is equal to 90. Okay, now I got the value of c. Okay, now this quadratic equation is complete because we got the value of the unknown constant c. Okay, now we can plug in this 90 for c in this equation, and we have to solve for the x. Okay, let me do it over here. So then we get 2x square negative 20x positive 90 negative 40 equals to 0. Then I'm getting 2x square negative 20x. When I combine these two numbers, I'm getting positive 50 equals to 0. Okay, when I look at the coefficient of x square, coefficient of x, constant, everything is a multiple of 2. So better we can divide the whole equation by 2 so that the numbers will become smaller. It will be easier for us to solve the quadratic equation. This 2 will cancel out, x square negative. When I divide 20 by 2, I'm getting 10x and positive 25 equals to 0 to 0. Okay, now we have to solve this quadratic equation. I think this quadratic equation can be solved by factoring. So for that, we have to multiply the constant of positive 25 by the coefficient of x square. So here the coefficient of x square is 1. Actually, we don't find any number in front of x square. We have to assume there is a coefficient of x square 1. So this 1 has to be multiplied by positive 25. When I multiply positive 25 by the coefficient of x square 1, I'm getting positive 25. Now I have to get the two factors for positive 25 so that the product of the two factors equals to positive 25 and the sum of the two factors equal to the middle term, that is the coefficient of x negative 10. I think negative 5 will work. So like when I multiply this negative 5 and negative 5, I'm getting positive 25. When I add negative 5 and negative 5, I'm getting negative 10. Okay, now to get the two values of x for this quadratic equation, I just have to change the sign of each of these two factors over here. If I change this negative sign, it will become positive. So the first value of x is positive 5. And if I change the sign, negative sign over here, again, I'm getting positive 5. Anyways, as I said earlier, I'm getting to same values for x. So we have to consider this is one value. That is solving this quadratic equation. I'm just getting only one value for x, that is x equals to 5. So the x coordinate at the point of intersection of the two graphs is 5. So according to the information, so A represents the x coordinate at the point of intersection. So therefore, the value of A is 5. We find 5 in option C. The correct answer choice for this question is option C.